G'day, this is the last in the automated garden set of videos. This mostly looks at finishing up the garden hardware, making a big barrel to hold the water for the irrigation system, plumbing up the pump and adding sensors to measure the water level. I'll do some tests and then should be ready to plant some tomatoes and test out how well the irrigation, the automation and the management functions work. I may end up doing another short video at the middle to end of summer just to see how everything worked out.
So I'm starting to put the irrigation plumbing together. So this is kind of what I think it's going to look like. A whole lot of little pieces here. So got a bulkhead fitting that fits into the bucket with the water in, right angled elbow, and then that goes onto a pump, just a little 12 volt solar powered pump. I got a motor speed controller in case I need to reduce the speed of the motor. I'm not sure how much pressure it's going to make at the moment. And then just a 1/2 inch coupler. I think I'm going to need to use a electric solenoid valve to make sure water doesn't flow through the pump when it's not powered on. And then finally that connects up to the irrigation system. So I'm using a Rubbermaid garbage pail to hold all the water. So let's get that set so I can connect it up to the irrigation. So setting up my water tank. So I need to put this bulkhead fitting through the water tank. I think I'm just using a force and a bit, but 1 inch seemed to be about the right size. So cut through the tank, clean it out a little bit. Just screw in the bulkhead fitting. Then we need to tighten it up from the other side, so there's some more fittings and seals on this side. It's looking good, so let's see how well things seal up. I want to do some tests on my water container and all the connections, the pump. I want to work out what pressure it's going to generate and how high the water level will go as I add more water. So I'm using this 10 quart or 2.5 gallon bucket as my measuring device. So first test is just to put 10 quarts of water in the big container and see if it leaks. So you can see this was a fail. So it looks like I need to wrap at least the metal to metal connections in Teflon. So let's try doing that. So I waited about 5 minutes and then checked whether there's any leaks. At least for the pieces wrapped with Teflon, nothing was leaking down. So I think we're in good shape. I also checked the water depth. This is with 10 quarts in the barrel, or 2.5 gallons. Then I added another 10 quarts, 2.5 gallons. So this is the depth with basically 5 gallons in the tank. So added another 10 quarts, so this brings it up to 7.5 gallons. And check the depth, I'm close to 8 inches, and remember I started about 3 inches with 10 quarts, so it's about 5 inches for 5 gallons, so 1 inch per gallon. So next test, I wanted to see whether water still flowed through the motor even if I didn't have the power on. So here's the motor hooked up. I put 10 quarts into an empty barrel and water just flows through it. So it looks like I do need a valve and a solenoid to stop the water flowing. So I want to check what the pressure looked like when I turned the pump on. So I wasn't sure whether I'd need the motor speed controller to adjust the pressure on them coming out of the motor. So I turned on the motor, got a pressure sensor on the end. Not seeing a lot of pressure there. It went up a little bit, maybe 2 or 3 pounds. And it, with adjustment with the motor controller, still sort of kind of just getting up to about 7 pounds pressure. So I don't think I need this motor speed control thing. This pressure shouldn't blow out the irrigation system. So I probably want as much as possible, just to make sure that it does flow. So final test here, I just connected up all the bits that I'm going to put on the irrigation system, so the motor and the solenoid controlled valve. Fire that up, see what the water stream looks like. Again, that should be enough to drive my irrigation system, but not too powerful, it won't blow any hoses or anything. Next thing I want to find out is just how much water I use on a typical watering session. So I've set the watering session up for about 180 seconds. We're at about 10 3/8 of an inch water in the big bucket at the moment. And here you can see I've set up some drip feeders just to test this out. Let's fire up the motor. I'll just adjust the drip rate on these to make it a bit more consistent across all the drippers. So in this case it actually ran for 210 seconds. So let's see how much water we used. So again, I'll just measure the water level. It's showing 9.5 inches, so we used about 7/8 of an inch or 7/8 of a gallon of water over that time period. One more thing I needed to do was just make a mount for my webcam, just so I can clip it to the PVC pipe over the garden. So this is kind of what I made in Fusion 3D. I'll add the design link down in the description below. Okay, everything's ready to put out in the garden now. So I trimmed it up a bit, got the barrel out there. The solar panel, it was a leftover one from the solar shed project, so that should work. Put the camera up. Put out the box with all the computer and electronics in, put in the water level sensor. That's the first one. So I have one in the front, one in the back. Okay, we're planting our tomatoes. I just watered them manually first and then started setting up the irrigation line from the pump. Kind of see how easy these fittings fit together. Just sort of push them onto the tube and then screw them in to fix them in place. So there's a large tube and then there's some small tubes out to the actual watering out by the plants. Keeping them low like this too stops the water getting all over the tomato leaves, they should keep them in better condition. So I filled up the barrel, got it up to about level 3 for these tests. Turn the pump on. And looks like things are working. And not too many leaks anywhere. So I just had to adjust the water heads here to make sure they're all even. So water's up at about level 3. We'll see how long this lasts, just with the watering schedule I've set up. I got a little bit of leak going from the pump out to the hose, but those drips won't really worry me long term. So I've been running the garden for about 5 days so far, so let's look at changes. I actually added another line of lettuce and a irrigation line. So this is what I'm seeing in the interface. So I go into the main overview here. I'm seeing my percentages for the soil, about 90%, 80%. They may be a little high. Everything else seems to be working okay. Water level, I've just filled up the water tank, so we're at level 4. Looking at the history, let's have a look at 3 days. We can see the changes in the weather and the humidity. It's kind of wet over these 2 days, cloudy and wet, so that's why there's less temperature then. And then we'll just check that the summarization works. So this is kind of the summary for each day of those temperatures. Let's go back to 3 day, and I'll just have a look at the irrigation, because this is kind of what I was keeping an eye on. I added a new line here to the chart, so this green line is the water level, so I wanted to see how fast the water goes down in the tank as the irrigation runs. I was getting about 2 or 3 days before it got down to about level 2, so I probably get down about there after about 3 days. But I noticed my soil was looking pretty wet, so I think I was over irrigating, and you can see here with these blips in the orange line, which is the number of minutes the pump ran. I was doing about 3 pump runs per day. I started off, I was doing it for about 4 minutes for each run, and that just seemed to be overwatering the garden. So I'm pulling back on that and reduced it to just over a minute watering in each session. I only got 2 watering sessions per day, so we'll see how that goes. As far as how wet the garden looks, I want to try and dry it out a bit, and it should extend the life of the water in the water tank too, so we'll see how fast that goes down. And the other view we've got here is just on battery power. So again, over the last 3 days, you can see it goes up during the day. You can kind of see when the sun hits the solar charger by when it jumps up and goes down during the day. So it gives me an idea of how much sun's hitting the garden during the day as well. So I'm probably getting close to 6 hours of a decent amount of sun each day. And these little orange blips down here again are the water pumps. So you see I reduced from about 4 minutes in each run. I'm running about 2 minutes for each run at the moment. And I also turned down the head of the irrigation, so less water came out of the irrigator. So again, we'll keep an eye on that and keep pulling back on the irrigation if the garden still looks too wet. And again, you can get a nice summary view over more than 3 days as well. That seems to be working okay. Last thing to look at is just the change to the settings. So I've reduced the pump time down to 100 seconds. An interesting thing is because the way the clock watcher works in the routine, it's only got 60 seconds level of resolution, so I can't sort of really do it at the second level. I may change that around in the loop, but at the moment I can just say if it runs for more than 60 seconds, then it's going to run for 2 minutes. If I run for under 60 seconds, it's only going to run for a minute. But at the moment I've got it down here, so effectively it's running for about 2 minutes for each run of the pump. And the other thing I've done is pulled down the number of times it runs each day. So I did have 3 times down here where I was running each day. There was over watering, so I just reduced it to 2 runs per day, kind of just after midnight, and then in the evening. And again, I'll keep an eye on that. I may just reduce this to 1 watering per day. May actually be better for tomatoes. Okay, I thought I was pretty much finished here. One thing I found when I put the Raspberry Pi Pico controller out in the garden, I was having trouble keeping it running. It seemed to run for about 3 hours and then would stop. So I'm going to show you a bunch of try accept code I put in the MicroPython code to try and catch what was happening. I was never really successful with that. It did make the whole thing more resilient, and in theory would tell me what the errors were, but I also set up a network monitor just to ping the device periodically every 5 minutes or so, and that seemed to cure it anyway. So I'm not sure whether there's something going on with the async code down in the MicroPython code that's causing problems, and just the act of pinging the network interface every 5 minutes fixed everything up. But I'll show you what I did for that. Shouldn't take too long, and then this really got me to the point where I wanted to update my network monitoring. I was using my ourProbes code for doing this. That's in another project. But since I did that, Google has removed the IoT services. So this is going to die in another 3 months or so anyway, just because the services it uses is no longer available. I did try using NEMS on a Raspberry Pi, which kind of works okay, but it was a bit too complicated for what I want. So I think the next project after this garden one will be one to create a little network monitor, probably running on an ESP32, but try and make it as simple as possible, kind of what my ourProbes was doing, but just make it all standalone and a lot easier to manage. So on the MicroPython side, I found I needed to log any errors I was getting when I was using the code out in the garden. So I created this little file called logger, and basically I can call write log line with a string, and it'll write that log line with a time date stamp out to a file called logger.txt. And I'm using this in a few places. So up in the main routine where I've got clock watcher, so this is the routine that runs asynchronously, fires up every minute. So I put some try accept code in here, so around the whole routine, try accept. It creates an instance of the logger and writes out an exception from logger as E, so we can see it's using this writing routine here, write exception. It's taking the exception. First it expands the exception, so this gives me the actual exception and the stack in the program, so I can actually see what was causing the exception, and then calls write log line to write out that line in my standard logging format. Whenever I get an exception here, all I'm doing is resetting the machine, so basically doing a full reboot. I don't get enough exceptions that I'm too worried about this rebooting at random times, and it won't really affect anything, so it's better to have everything start from scratch again if I get an exception in this clock watcher. The other thing I've got in here now is if the network gets disconnected, so every time this clock watcher wakes up, it's going to check to see if the WAN's still connected. If it's not, then it goes and writes out to my logger what happened and when, and then does a machine reset. And the final part where I'm doing a reset is down here in the main routine, where it fires up the actual MicroDot web service. If that fails, then it calls up the logger routine. In this case, it can't get the exception for some reason, so all I can do is write out that MicroDot had an exception and then do a reboot again. Some other routines I put in here is just a couple of couple of web services. Let's find it up here. Okay, one to call log, which just returns the current log as text. I don't have a user interface for this, so I just call that manually from a web browser to get see what's actually in the log file at any time. And then I've got a log clear too, so it allows me to clear out the log if I have too many entries in it. Since I've put all this in, and like I said, since I've got network monitoring going on the device running in the garden, I haven't had any more problems. So basically all I'm getting, and you'll see here at the beginning of the main routine, is I log when the routine started up. So it just shows that there was a restart happen, and that's all I'm seeing in the log at the moment. Every time I repower the device out in the garden, I just see the restart, but I haven't been getting any of these exceptions, which is good.